this second video, we're going to have a look at 3 examples of finding the area under the curve. And the first one is where we've got a curve C, has parametric equations, x is 5t squared and y is t cubed. And we're looking at finding the area between C, the x-axis, and the 2 lines x is 5 and x is 20. So let's have a look at that. So there's our parametric equations. So what are we finding here? We're finding the integral from where x is 5 to where x is 20 of y with respect to x. Now, that could be written as the integral. Now, substituting for y is t cubed, and we know that we can go dx dt. So over on the right hand side, I'm going to differentiate my dx with respect to t. So we've got x is 5t squared, so dx dt is 10t. So then we can write t cubed, dx dt is 10t, and then dt. And we mustn't forget to simplify this. So we're going to write the 10 on the outside, and then t to the power 4 dt. So integrating that, we've got t to the power 5 and then divided by 5. Now let's have a think about the limits. So we know that when x is 5, then t will be equal to 1. And I think we're going to assume here that t is greater than or equal to 0. And then x is 20. That gives us 5t squared is 20. So therefore x or t must be equal to 2. So we've got our limits now. T is 1 to where t is 2. So substituting, we've got 2 to the power 5 minus 1 to the power 5 gives us 62. So that's our first question. Second question is this one here. So we've got a curve given by these parametric equations. So t squared and y is 2t times 3 minus t. Now the first question says, can we find t when x is 0 and when x is 9? Now when x is 0, we've got t must also be 0. So let's write that down. So t equals 0. And then when x is 9, then t squared must be 9. So t must be plus or minus 3, but we've got that t is greater than 0. So t must be equal to 3. So t equals 3. So those are going to be our limits when we integrate. So we're going to integrate from x is 0 to where x is 9, which is t is 0 to t is 3. Now, we need to find the area R, and the area R is actually going to be from where x is 0 to where x is 9. And when t is 3, we can see that y is 0. So we've got this enclosed area here. So integrating to find the area, we're integrating y from where x is 0 to where x is 9 with respect to x. And we know that that's y, which is 2t times 3 minus t. I'm going to expand those brackets. So 6t minus 2 t squared, and we need dx dt. So over here on the right, I've got x is t squared, so dx dt is equal to 2t. So putting that in, we've got 6t minus 2t squared times 2t dt. And I need to remember to simplify here. So that's going to be 12t squared minus 4t cubed dt. And then integrating that, I've got t to the power 3, so that gives me then 12 over 3, which is 4, and then minus t to the power 4, so that would be 4 divided by 4, which is 1. Now I've got to think about my limits, and I know that when x is 0, t is 0. And we've also said that when x is 9, t must be equal to positive 3. And so substituting, I've got 4 times 3 cubed minus 3 to the power 4. And then when I substitute 0, I know I'm going to get 0, but I'm going to write down minus 0. And that gives me altogether 27. So that's our second question. Now our third question is this one here, and it's given by the parametric equations t squared plus 1 and y is t. Now let's sketch that curve, and I've drawn it on the software, and it looks like a parabola on its side, and it crosses the axis at x equals 1. So I can try and draw that in. So it looks something like this, and is symmetrical, and it crosses here at x equals 1, and we're looking at, for finding the area, the region R is the enclosed region between the curve and the line x equals 5. So let's draw in that line x equals 5. So what we're doing is finding the area of this enclosed region between 1 and 5. And I could just type in the 5 there. So I'll just change that to a 5. So we're going from where x is 1 to where x is 5. Now we need to remember that when we integrate, it gives us the area between the curve and the x-axis. So for our final answer, we'll need to double what we get when we integrate. So let's integrate that. So we need a new page here. So our question was x equals t squared plus 1 and y equals t. And we know that we're just looking for the top half of that area when we integrate. So that goes from where x is 1 to where x is 5. Now, if we integrate or differentiate rather our x, so we know that dx dt is equal to 2t. Now another way of doing this is to treat this bit, dx dt, like a fraction. So we can then write dx is equal to 2t dt. So we can replace dx with 2t dt, and that's a little bit quicker than the other method we looked at. So what are we doing? We're integrating y with respect to x from where x is 1 to where x is 5, and that equals the integral y we're going to replace with t, and dx we're going to replace with 2t dt. And then we can also replace the limits x is 1. So when x is 1, t must be equal to 0. And when x is 5, t must be equal to plus or minus 2. That's probably going to be the case that the positive 2 will be above the x-axis and negative 2 will be below the x-axis. So let's just choose the minus 2, the positive 2. So let's integrate that, or let's simplify first. So we've got when t is 0 to where t is 2. I'm going to take the 2 outside and we're left with t squared. And if we integrate that, we've got, I'm going to leave the 2 out there, that'll be 1 over 3 t cubed, and that's from 0 to 2. So then we've got 2 times a third times 2 to the power 3, and that would be minus 0. So we're left with 2 over 3 times 8, which is 16 over 3. And that's our answer. Now, if we remember, we need to find the top and the bottom. So what we need to do is double our answer. So R, so the area of R is equal to 2 times 16 over 3, which is 32 divided by 3.